work on fraud detection, you work at SAS, you work at IBM, you learn a lot about AI, and then in 2017 you joined Google.
I still tell people learn the basic of Linux, learn the basics of containers, learn the basics of SQL. I think it's very valuable to have those skills. Anyone has ever read the machine learning principles from Google? It's written by some of our engineers and researchers that are like years old.
Yeah.
And when I read them still now, they're still true. And the first one I love, shipping a Gemini use case or LLM use case in itself is not a goal. The goal should be you're trying to solve a problem or build a feature or something.
I'm keen to have your thoughts on Gemini vs other open source models or closed source models. Like, what do you think makes Gemini different than the other models? This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist and I will be your host. So today our guest is Erwin Huizenga. Erwin is a machine learning lead at Google and has been at Google for the past 7 years. Prior to this, he had a bunch of experiences. He worked at Stormbits, at IBM, at SAS, and he also did a Master of Science at the University of Amsterdam. Erwin is an AI expert. He's an expert in applied AI, in deploying models in production, and in MLOps. A couple of months ago, he released a course on LLMOps, and he was also quite close to the Gemini launch. So we're going to talk about all of this in this episode. If you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, let's start now. Hi, Erwin. Very happy to have you on the show. First thing I wanted to ask is, how did everything start? How did you get into this world of data and AI? How did you get into the field?
That's a great question, and it feels a long time ago, and I feel very old now. But let's go back a bit. It all started when I finished my master's degree, where I focused on some statistical techniques, and I ended up at a startup. So this was a tech startup in Amsterdam, and this tech startup had built voice over IP software, and they also had a application similar to Twilio, MessageBird, that could do sort of messaging across different channels, SMS, text, email, even old school types, back like phone calls and things like that. So, and I started there as a data scientist. Sort of back then, it wasn't called a data scientist. We were all just engineers hacking away, building things. And I worked on some fraud detection models and some pieces of the core application as well. So that was my sort of first step into the field of technology. I learned about cloud. We migrated to AWS back then, which they were one of the first having cloud technology, and we had a tech lead who came from Amazon, so we built on AWS there. And I was involved in building the system and worked on different use cases. And we ported actually our code from a Java web application to Python and Django. And it was the battle between Ruby and Ruby on Rails and Python versus Django. So that's when the early days when Python sort of became more popular. So a good introduction into working with cloud, with data and Python.
When was this first experience? In what year?
2010. It's more than 10 years ago, Neil. So it's a long time ago. You're putting me on the spot here. It's
okay. And already working on fraud detection, like what kind of models were you using there?
Yeah, so back in the days, like now we call everything artificial intelligence, machine learning, large language models, generative AI, all the
Mm-hmm.
fancy terms. Back in the days, it was just statistical models we were doing, basic decision trees. We called it data mining back in those
Mm-hmm.
days. There was no data science, no data scientist role. So that was all later on. So we worked on very basic models. Sometimes it was rule based, but yeah, decision trees, regression models. So very basic, but in those times it was the most advanced we could come up with.
Yes, before all the deep learning and Gen AI
Oh
stuff came
yes,
up.
yes, definitely. You had to
And
build a lot from scratch because there were no libraries that we have these days. So it's like TensorFlow came later and those things. So it's yeah, it was very early days.
so why did you stay in the AI field? Like, what did you like about AI that made you stay in this field?
Yeah, that's a great question. So I learned early on that I love working with data, and I loved sort of using data to solve problems. And I think I then discovered sort of the field of back then I called it data mining. They called it machine learning. It's like advanced analytics or predictive analytics. They called it those types of things. And I learned that sort of started learning about that field, and there were people actually building models. Back in the days, it was maybe at a bank, risk models, or so. I thought, okay, you can actually uh, do a job where you work with data and work with with these types of models and building these models. So I slowly started moving to that field, and then realized that there's companies that are specialized in sort of technology for solving these types of problems using AI, but statistical techniques as well. And I got um, introduced into SAS, which was a predictive analytics company for 40 years. So they have been building statistical software for 40 years. So they were sort of the standard back in those days for a lot of companies who built predictive models, like banks who did risk modeling or fraud detection, or if you had to do any statistical modeling, those were sort of the software that you used in those days, or you do data mining, things like clustering or decision trees, right? So I started working there, and I realized that you can do a lot of fun stuff with this, and slowly started sort of then also the trend of data scientists came up. So then everyone started calling it data science. So
Mm-hmm.
there was this whole buzz, and I think um, I was lucky enough to be sort of leaving university, and when that field of data science came up, I think everyone before me, they maybe did a master's in AI or math or statistics or computer science, and then they ended up as a generic developer because there weren't sort of many data science roles back in the days. So I was lucky being there at the right time, and growing up sort of um, going through that journey while it became more and more popular. And you saw also the field of data science sort of expanding to other companies, right? You had the startups working with data, you had consulting firms doing data science, so it became more and more popular. And I really realized that I enjoyed it a lot. I still do, doing hands-on work. And so I started sort of developing myself and learning about neural nets and things like that. So slowly going into more advanced models. Worked a bit at IBM in the Watson team. I think IBM was a bit early with sort of on the
Mm-hmm.
with everything they built. I think now the time is there for these like natural language type of understanding, NLU techniques and things like that. So they were a bit early, but yeah, learned a lot, and then ended up at Google after a while as well. But I learned a lot working also at SAS because I learned a lot about folks who were in the field for a long time, who had a very solid background in statistical modeling, but also data preparation, right, which is a key part of everything we do,
Mm-hmm.
like making sure you have good quality data. Still, it is. So I learned a lot about that, like processing data, large data sets, learning to write proper SQL, those things you typically don't learn in university. At least they didn't teach me. I'm not sure if you all if you followed those courses, Neil. But so I learned a lot of those hands-on skills, but also more theory. So and slowly also worked on more applied use cases. So like you said, I've been always been focused on the applied side of things. So solving use cases using AI machine learning.
So I'm curious to hear how you learned all those stuff because I mean, you started quite early. I guess there
Yeah.
wasn't any Coursera course on LLMOps available at the time. So how did you learn all those things?
Yeah, that's a great question, and that's a question I get a lot, especially from folks moving out of the sort of university and then going into the field. I think a few things that help me, and give this advice to others as well. And of course, I'm an N is one, but what really helped me is that I started at a startup where I did a lot of hands-on work. So I had to do coding. So we had some Java. I learned Python a lot. So just coding a lot and writing code and solving problems helps you. Later on in my career after startup, I learned sort of working with data and what having high quality data means and how it impacts your use cases. I learned about the different techniques that were there. So at first, it was, of course, the basic types of models that I mentioned, like decision trees we use, logistic regression. We started slowly with some feed forward neural nets, some basic neural networks and things like that were there. So I learned about those techniques and just applying them and seeing sort of what works, what doesn't work, um, uh, trying a lot of different things. And I've always been someone who just builds things and tries things by himself and then also keeps learning and growing. So that's why I love now doing the courses as well to help teach others because but yeah, back in those days there was not a lot. I was lucky to be at SAS where they already had a lot of courses on like neural, they already taught some courses on neural nets and the basics, although they weren't the type of models we have nowadays, but very basic concepts models, but also the, like I said, the statistical models, or how do you do proper data wrangling, data preparation, and basic things like writing good SQL is still very valuable for me these days. Like if I need to get some data from a from
Mhm.
a database, I think writing SQL is very handy. So it's just throughout my career, I noticed it's important to keep learning. I enjoy doing hands-on things, so that makes it easier. I think, Neil, if you enjoy doing that, and I always tell students now as well, is that start with trying to solve some problems. Right, just choose a data set, choose a problem. Nowadays you have the Kaggle
Mhm.
platform or other platforms, right? There's these amazing websites that teach you things, deep learning AI, and beyond that, where you have a lot of sort of code examples. But I think that helps a lot. And for me, starting at a startup has helped a lot because I just had to do a lot of different things. I even had to learn basics like we had cloud technology and we had service in that we hosted as well, and like I learned about like, okay, how do you
Mhm.
like if you have cloud technology or cloud service, like how we have the SSH into it, and I had to learn about Linux. I had to learn about like all those things as well. So that has helped me a ton working closely with software developers as well, and with cloud technology. So it's just a mix of things, and mainly because I like learning. I believe in
Mhm.
continuous learning and solving problems. That has helped me a ton throughout my career.
Yeah, no, I definitely agree with you that building stuff is actually probably the best thing to learn. I get so many people messaging me on LinkedIn. Can you recommend a book, a paper, or a course? I mean, obviously it's great. Like it's great to watch a course if you don't know anything about a topic or read a book, but the most important thing is choose a problem, take some data sets and build something by yourself. You will just learn much more than reading 100 papers.
100% agreed, Neil. And especially if you take maybe some problems that are like in university, we get clean data sets, we get small data sets. So I don't know how it is these days. Maybe
Mhm.
they improved a bit, but back in my
It's the
days,
same. It's the
okay,
same.
everything runs on your local machine. It's easy. Everything is clean, no problem. Especially if you do something where the data is not very clean, where the problem space is not very clear. I think then you learn sort of that it how to work through those challenges and problems, and especially nowadays, right? You have all these great APIs, and we'll talk about that probably later as well, like a Gemini API and things like that. But just taking an open source model and deploying an open source model that maybe doesn't fit on the CPU, but you have to deploy it on a GPU, right? You run into all these challenges that you sort of have to solve and work through. So I agree with you. Taking some of those challenges and trying to solve them by yourself. And I also love it because you always see that everyone has their own approach,
Hmm.
and you can learn from others. So yeah, you can definitely learn from a book. The theory is there, and you have now these great courses. But I think the practical, the applied piece, I fully agree with you. You learn best by actually doing, working on those problems.
Okay, so you work on fraud detection and then you have a few experiences. You work at SAS, you work at IBM, you learn a lot about AI,
Yeah,
and then in 2017, you join Google. Can you
yeah.
talk about this? Why do you decide to join Google? And yeah, maybe also talk about your career there. You've been there for 7 years. It's been quite a while. So, what did you do at Google?
Yeah, for Google, that's a long time. 7 years. There's folks that are way longer at Google. At 7 years is quite some time. So, yeah, it's been quite a journey. So back in those days, someone from Google reached out and said if I was interested in a role to apply. So I was like, okay, sure, It's Google, right? I'm We can always have a chat. So I applied, and then you go into the Google process. Um, for me, it was a very long process. It differs per role and everything because one of the roles I think they stopped hiring for, or and then it stopped, and then there was a new role. So it's sort of that's. I think for many Googlers, that's sort of a journey you go through, and then you end up in Google. I know very few who sort of you apply, you do a few interviews, and it's done with a few months.
Hmm.
It's sort of it's not a straight line. So for me, that was definitely the case. And then it's actually interesting. Then I said no to a first role they hired for, which was a generic cloud engineer type of role. And I felt as a data scientist or a
Hmm.
ML person, like we both are, Neil, that I don't have sort of the skill set for that. I've worked with cloud, but being a generic cloud engineer, like work on deployments and applications, is a different skill set than maybe what we have. And so I said, oh, maybe that's probably not a good fit because I also realized I wanted to stay within the field of data and data science because 2017 was already more and more traction. There was more happening. It wasn't exploding as much as it is these days, and we'll get there probably as well to talk about that. But it was getting more popular, so I was like, okay. And you had TensorFlow coming up, so Google was already publishing papers, and TensorFlow was there. Very rough, and I'll talk about that later as well. But so I decided to stay within the machine learning field and not go for a generic role. And then literally on Friday I said no, and on Monday they called me back saying we're going to recruit for ML folks within Google Cloud. Google Cloud was very early back then. Very few people still in cloud, especially in Europe. So I started in Amsterdam. So and then I was like, okay, I can do machine learning at Google. That is interesting. And within the cloud space, which I think was a big plus for me as well to do in cloud and machine learning in the cloud, because I had this gut feeling that would be popular in the future, and I think cloud would be a very good skill to know as a machine learning data science person. So definitely learn if you want to learn something, definitely also learn cloud skills as well as a data science person or a machine learning engineer. So then I went for that opportunity, and I started off in the EMEA team in Amsterdam. So we were a very small team, and we worked with the largest sort of Google Cloud customers, so digital natives across EMEA, and we were only two or three folks back then. So that was a quite interesting journey because I worked on a lot of different things. But yeah, that was your question was what's your journey into Google? That was sort of the journey. It took me actually 10 months from the first
Okay.
time they reached out to sort of starting my first day. So it was a long journey, and Um, but in the end, I didn't give up, and I got there. So it was a good next step for me. I felt it was a natural progression in my career, especially like I said, for the cloud component was very important for me.
No, yeah, I'm keen to learn more about this experience. Like, what was it like, the cloud, early days of the cloud? Now, I mean, I won't say everyone, but so many people use either GCP, AWS, or Azure. Like, they are so popular to do
Yeah,
so many ML stuff, training
yeah,
models, deploying models, whatever you want.
yeah.
What is it like at the time? And maybe we can dive into one project that you worked on there. Um,
Of
yeah.
course. It's a great question. In my opinion, I noticed that the early cloud is a game changer. I think especially for machine learning, because machine learning workloads are very spiky, right? You need compute resources. You're done training and skills. Sort of, you need to be able to be very flexible in that sense. So I think it's a game changer. And how things went early in my career, I remember days where we did projects. Uh, when I did sort of consulting type of work when I was at SAS, and I know you did this as well, is that when we went to a customer, we actually sometimes had to bring a server, an extra server, in the car and drive somewhere for a project and just install the server in a room. And like and nowadays, right, I just spun up some resources, and you just get whatever you need. So I think those early days for cloud was, I think, people had to get used to it, and it was mainly, I think, startups and digital natives that were building on cloud because they needed to scale
Mhm.
quickly, and also they had the skill sets sort of to build on cloud. So it was small in the early days. I worked a lot with digital natives across EMEA, done some work with the Spotify team. They were quite early. They've talked about this a lot. Some of the other, there have been startups that we worked with. So it was mainly the sort of folks who grew up in the digital space back then. And there were, of course, also more traditional enterprise organizations building on cloud. But for them, it sort of started a bit slower, I think.
Mhm.
Especially, I've seen this across Europe. I think I don't know. You can tell I've been living in Asia now for a few years. Maybe Europe is a bit more conservative sometimes than the US or
Mhm.
some other parts. But now, yeah, of course, it has taken off. So it was we were a small team. We didn't have as many products as back then. There was TensorFlow. Oh man, TensorFlow one. It I still remember debugging that code. It was always the tensor shapes and weird error messages. Like nowadays, you have everything is clean. There's like TensorFlow and with Keras API is amazing to use, right? There's PyTorch these days, Scikit. There's Hugging Face with their model. So it is these days it has changed so much. And I want to sound old, but those days it was very rough, and it was very also with things like TensorFlow, but also cloud, very engineering heavy.
Mhm.
And I think now it's easier probably for a data scientist to build things in the cloud and to scale things in the cloud. So yeah, it was interesting to go through. I learned a lot. And then the machine learning, the deep learning came up, right, with the TensorFlow models, and then also folks had to run these models. So machine learning engineering, MLOps became popular. So that slowly developed, I think, also thanks to sort of cloud that was there in general, and but also people deployed more and more models. So you need to manage things, you need to scale things, as you know. So yeah, that was a very interesting journey, and I think looking back, things have moved so fast, right? If 2017 there was cloud usage, but if you look at the cloud users now, and you
Yeah.
probably see this more,
Mhm.
Neil, you could probably answer this question better.
Mhm.
It's the adoption has increased a lot, I think, the past years.
I mean, yeah, I work in consulting, and
Yeah,
we very very often work either on GCP, AWS, or Azure for Gen AI and for traditional ML problems as well. Um, Before that, I was at a startup. We're using a bit AWS, but we had our own infrastructure, so I was kind of in my niche. But now that I'm in consulting and that I explore different different companies, I can tell that pretty much all of them have some kind of cloud infrastructure set up. So yeah, cloud is definitely huge.
And it makes life easier. I still remember a story. We were in Amsterdam, and we hosted a couple of servers in a data center somewhere ourselves. Just like you said, we had our own servers, and we of course we were migrating to AWS, and then a intern had shut off the server because he, just like with a computer, he thought you should
Mm.
shut down your sort of resources. So we had to drive all the way to the data center to sort of and get in, and it's very difficult to get into these data centers. You have to show your passport and do all these checks and things like that. So to manually restart the server, and not, yeah, and like I said, we had to maintain servers in those days. So yeah, now it's become easier. Sort of resources are more general available, I think, for data scientists and machine learning engineers to build use cases, which I think is pretty cool. Makes your life
Hmm.
easier.
Yeah.
I hope, at least for me.
Yeah, I'm impressed by, I mean, the big plus of cloud infrastructure is that you don't need to manage and even understand everything that's under the hood. Like you can,
Yeah.
for example, I can deploy an app with one Google
Oh yeah,
Cloud command and the app gets deployed. It's like made magic. And obviously, you need to understand a bit how it works. You need to
of
set
course.
up the CPU and stuff like this, but everything is set up for you. Same if you deploy a model on Vertex AI. I mean, you know the
Definitely.
syntax, you deploy a model and then it's there, and it's a bit feels like magic. It makes things much easier.
It is. I also want to tell folks, right? Because you asked me what do you learn, and we talked about what sort of how we answer the question when we get it from folks starting in this field. I still tell people learn the basic of Linux. I think that's a good skill to have. Learn the basics of containers. Learn the
Hmm.
basics of SQL, because I think, yes, a lot of that is abstracted away these days and made easier. I think it's still is very valuable to have those skills, because at some point you probably need that as well, right? You need to maybe SSH into a machine to figure out to sort of debug some things. You're probably going to create a container here and there, or you're going to work with containers. So having those skills, I think, is very valuable for folks to learn. So when you're learning, try to also sort of go with projects where you maybe don't have that layer of abstraction, but just start a few
Hmm.
layers be- below, because I think you can learn a lot from going through that and debugging and understanding how things work. But yeah, we're lucky that our lives got a bit easier. I don't have a server in my car anymore in the back to.
Hmm. And in terms of cloud, what do you recommend? What are the services or the things that people should learn if they want to be impactful with AI?
It's a great question. I think I mentioned a few already. I think having Docker skill, like, it depends on what your goal in your career is. Like, it's like, I think both of us are very applied. We build use
Hmm.
cases. Others want to go into research. I've spent a bit of time. I'll probably get there as well with in Zurich with doing rotation with research and all the work they're doing. Um, so it depends on where you want to go. So if you really want to become an applied machine learning engineer, data scientist, however you want to, or applied AI engineer, however it's called these days, I think it's good to have hands-on skills across different technologies. So, like I said, must for me is definitely, of course, Python and SQL. If you know those well, I think you can do a lot of different things. You're very flexible. From cloud perspective, I think what's good to learn is anything with just having some Linux skills is always good. I think it's also good to learn, as I mentioned, about Docker containers, about
Hmm.
containers in general. How do you package code? And I think also a few generic sort of development skills is good. Like, how do you structure your code properly if you do those deployments? How do I wrap up my code into an API and things like that? So I think learning that all those skills is helpful. But now I'm summing all of this up, and it sounds like we have to be like unicorns. We have to know
Hmm.
everything, which it can be a lot to learn as well. But I think those skills will help anyone in their career. I think in this field.
So we talked a lot about cloud, about API. You mentioned the Gemini project. So let's dive into this one. Well, for those who don't know, Gemini are Google general AI models, similar to ChatGPT in some sense, or competitor. Yeah, you've been close to the launch. So can you talk about Gemini? How did the launch work? What did you work on? What did you do there?
Yeah, maybe I'll talk a bit about what my team does, and later on, if you want to know more about things I've done at Google, we can also talk about different roles I've done. But so in my career to how to grow it. But
Mm-hmm.
yeah, this is sort of what we've recently done, and my team, we're we're part of engineering, and we're sort of a team of developers where we sort of we do a lot of different things. My team, it's quite a team of a very diverse team, and a lot of sort of it's a bit of a unicorn team. So we do help the product teams with all the launches. So we build a lot of the examples and assets that developers and practitioners use to sort of build their own use cases. So we've launched a repository with code samples for Gemini with best practices. I built some examples for tuning and how to do sort of tuning on our previous model, Palm. So we support the launch with a lot of the technical assets. So we build a lot of best practices, examples, code that sort of everyone can use. We also are often the first users of the product, so we try to break it and give feedback and test it and do things like that. We also do a lot of enablement of folks. So we do a lot of like you said, I've done a course with deep learning AI. We do podcasts, video. So we try to educate folks. We're a team that sort of um, help practitioners to be successful building machine learning use cases, if it's open source or cloud, whatever technology someone is using. So in whatever way we can help people be successful with the machine learning use cases, that's what we're trying to do. So the team is very diverse. We do a lot of different things. And yeah, we've been very close to, of course, first we launched the Palm model family
Mm-hmm.
early last year. So it was a very busy year for us. Last year, we worked on a lot of great stuff. So we create a lot of the examples that are there, the assets. We created sort of educational materials for folks to sort of get up and running on everything. Because yeah, releasing a model or an API is one thing, but we all need more than that to build sort of use cases on top of it,
Mm-hmm.
right? So we've done that, and then we've been working on the Gemini launch. So the Gemini Pro model that came out first, and we built a lot of those assets. We tested things. We helped with the SDKs. So we did a lot of different things, and we're still working on that as well. There's I can't say much, but there's more to come soon, and I'm working on some cool stuff as well that I'm going to publish soon with the deep learning AI team again. So yeah, so we like I said, just to sum things up there, my team really is a team of engineers that works with the community
Okay.
to help them be successful with our models, with machine learning use cases in general. And we go from like from sometimes we teach folks on I've teach folks on machine learning operations, like how do you build, what are some best practices or patterns to build, like how do you maybe do distributed training on things like TPUs. I just wrote about reinforcement learning. So we teach folks and help folks on these topics. So it very much fits to what your podcast is doing as well. We believe in enabling people to be
Mm-hmm.
successful in this field, and that is what my team been working on. And yeah, we work closely with teams across Google on the Gemini launch. So there's different APIs. There's the developer API for Gemini. There's the cloud API. Of course, the model comes from the DeepMind research team. So this is so the Gemini launch is very much a collaboration from many different teams at Google. It's not easy to do
Mm-hmm.
to ship these things, and it's not only sort of exposing a model as an API. There's much more that comes with that, and it's been a I enjoyed it a lot to be close to that and to help with that. And the feedback has been has been good. So we're now doing a lot around showing what folks can do with multimodality. So using different modalities like video, audio, text. So going beyond what we've seen with Palm, which is only text to text, right? Where we what we had to now showing the power of different modalities, but also like other techniques, like we've done, like I said, supervised tuning for Palm. We've done reinforcement learning. So yeah, very exciting. It's I'll be honest, it's also for someone close to everything, it's difficult to keep up with everything that's
Hmm.
happening within Google, outside of Google. It's There's so much happening, Neil. So I'm curious to hear how you keep up with all the progress in this
Uh,
field as well.
I mean, you can't keep up with everything, right? You need to choose. I
Yeah.
mean, you need to work on your project, do stuff, and then some. Yeah, couple of times you see a cool new model, you test it, you see how it performs, but it's quite,
Yeah.
yeah, quite challenging to keep up with everything. Now it goes so fast. It's, yeah, impossible almost.
I think it's almost. I don't think there's anyone who's
Mhm.
across everything. So I try to focus as well, and now do. And I'm gonna. I'm very excited about the Gemma open source models that we released. So I
Mhm.
really wanna. I'm very eager to do a bit of work on that in a couple of weeks. To do sort of to create some, or to help the community to do sort of tuning using the Gemma
Mhm.
models. I'll try to do some work on that as well and publish some.
What are, sorry, what are Gemma's model? Are there smaller models? Is that
Yeah,
those
those are
ones?
smart. They're Yes,
Okay.
exactly. So I haven't used them yet. I haven't had the
Mhm.
time because we are still doing some Gemini stuff. But in the coming weeks, I'll be trying them out as well. But yes, they are the open source smaller models that we released, and they're available on, for example, on Hugging Face and in Keras. So and I have heard pretty good feedback. So very excited to do some work on that as well.
I've got two questions on Gemini. The first one is I'm keen to have your thoughts on Gemini vs other open source models or closed source models. Like, what do you think makes Gemini different than the other models? Or is it different?
Yeah, it's a really good question, and it's a question I probably get every day. So, like, I don't, whatever you ask me, even if you ask me about the different open source technologies or different clouds, what's the difference? I never like to talk about what others do. I like to talk about like what we do and what I worked on, because I can't judge everything either, right? I
Mm-hmm.
haven't. So I think before I answer your question, I think it's all, whenever you're working on large language models and generative AI, I think what is very important that you have a testing mindset, because it's not always that one model works best for all of your use cases. And you know this as well, Neil, is that it's always about testing different models,
Mm-hmm.
and nothing is different now. So you have to think about how do you properly evaluate your models for your use case, not only sort of using automated metrics, maybe an auto side by side or like standard evaluation metrics, but also human evaluation, right? Get your users to test, give feedback. So I think having a testing mindset was already important with machine learning. I think it's now even more important with these models. So that being said, there's it's very difficult to compare because so like I've worked with Gemini, and I worked a lot with Gemini and try things. What I really liked about it is a couple of things. Is the multimodality. I think that is very powerful, giving different modalities in sort of one API request and combining
Mm-hmm.
text and images. So you don't need different models. I think it's very strong on that from what I've seen. What I've seen as well is that the reasoning is very very good. So especially if you do advanced reasoning, there's some good examples in the paper as well, where like grading homework and combining text and images, and then sort of drawing conclusions from that. I've been very impressed by that. I've also been impressed by sort of the speed. There's a way to sort of stream the response of the models. We know that these large language
Mm-hmm.
models take some time to respond, and there's some options to sort of get that feedback quicker. So I think those things I've been very excited about. It opens up not always per se new use cases with multimodality, but it becomes easier to sort of solve complex use cases that have text and images and video and things like that. And I've seen definitely some new cool use cases as well
Mhm.
people build, but it's very difficult for me to say for this use case it's always the best for that. I've seen that those things are it's really good at, and I like I said, just try it out yourself and see what works for your use case. And like models are being updated as well all the time, improved. So what might be good today
Mhm.
maybe is not the best option in a couple of weeks. But I think with Gemini, definitely what I really liked was the reasoning is very strong there. Also the multimodality, which I think is very powerful. The context window, which I think has everyone talked about. I think I saw a tweet from Jeff Dean on the finding a needle in a haystack type of use case. So there's many different things I've seen. I think that the paper also describes a lot, like a lot of the benchmarks that have been done
Mhm.
and things like that. But yeah, I've been excited
Mhm.
about that, and especially like I said, I as an applied person, I really liked the multimodality as well um, of the model. But I still also love, like I said, the Gemma open source models. I just find it fun to also work with open source models, just because I'm a very applied and ML engineer type
Mhm.
of person. So I'm looking forward to working with that as well.
Yeah, I think it's interesting that you mentioned that, yeah, different LLMs are good for different kinds of tasks. I think I read an article. I saw an article. I don't even think I read it, but I scanned through it, of rerouting your question towards different LLMs. So you've got a bunch of LLMs, Claude's, Gemini,
Oh yeah.
ChatGPT, well, whatever. And then you, based on the question that you ask, you have some kind of routers that's going to ask the question to the best LLM for that specific question. And I found this quite interesting. Although it means more LLMs in your system, so more possibilities of failures. I mean, the more models, the more difficult. But
Yeah.
I found this idea very interesting.
That's smart. That's actually a good way. And probably people do it as well. What is the cheapest at this moment to ask
Hmm.
the question? Those things are also important. Like what I see changing now and coming back to the applied field, like when you build use cases with these types of models, Neil, is that I'm curious to hear what you see as well. Is that in a sort of a few months back last year, it was very much about what is the best model now. But now people realize that there's more things that are important for use case. So first of all, is like what's the best model for your use case, not maybe what's the best model on these generic benchmarks, right?
Hmm.
Evaluation. So I think like figuring out what's the best model for your use case, one thing. Secondly, then it's beyond the model as well, right? Maybe you need to do some RAG, so you need to fetch data from somewhere. It could be an embedding or something like that. And put that into your prompt and that goes into your model. Or like
Hmm.
if you do multimodality, you need to fetch your images from a storage somewhere. So it's also maybe you have the requirement to run a model within a specific region. Maybe your data can't leave the EU. We know for a lot of the European companies that's also important, right? And we see that here in APAC as well. It needs to stay within a specific region if you're a government or a bank. So that is a requirement. And then cost is something that comes in, latency is something that comes in. So I think it's a way more complex puzzle for if you're building use cases to sort of put together than only quality. Right? Of course, the discussion within the academia is mainly around overall performance. But I think when
Hmm.
you work on applied use cases like we do, other things become important as well. And now I see people like, oh, I've been working on prototyping, but now we have to bring it to production. Oh yeah, I haven't thought about maybe some of these other things. And it's also
Hmm.
y- we're all learning, right? That all these other things become important. And I think especially with these LM use cases compared to maybe traditional machine, well, let me call it traditional machine learning, like I talked
Yeah.
about in the past, where we have a statistical model or decision tree. It's just we deploy that, we do scoring on that, maybe batch or as an API. We have to fetch some data that goes into the model, and then we get a response. It's pretty straightforward. Now if you have a use case, it can be way more complex. Like I said, maybe you need to fetch an embedding that you want to include in your prompt. Maybe you need to get an image if you're doing multimodality. Maybe you're routing across different APIs, like you said.
Mm.
Maybe you need to do post processing to check if there's nothing in the response that you don't want to show to your user. So it is a way more sort of complex sort of set of components that we need to build in order to bring these use cases to production. So I think I think that is something that we're all learning now, and we're all figuring out how to do that, and which I find very interesting because it's something new we're going through. But now I feel everyone is realizing that it's especially when you bring a use case to production, it's there's a lot of different requirements we have to think about, and probably you see this in a day to day
Mhm.
in your day to day work as well, Neil, with clients.
Yeah, yeah, no, of course. I mean, it's one thing to do a proof of concept and to get a model in a notebook, but deploying your solution and having an actual product that works. I said problem because yeah, obviously when you deploy, you get 10x more problems. But yeah, having an actual product that you deploy is a completely different story. And actually, you mentioned this topic. So deploying Gen AI models is
Mm,
difficult. You did a course on LLMOps, which is strongly
yeah,
related to deploying models. So yeah, I'm keen to dive a bit into this one. Like, what
yeah, of
is
course.
LLMOps? You did a course on that. So what's your course about?
Yeah.
And yeah, what are the key challenges there? How can we deploy LLMs in production?
Ooh, great question, and it would almost be a topic for a separate podcast. So I'll try to keep it short, Neil. Is that look, I didn't. Andrew really wanted to call the course LLM ops because that's what everyone knows in the community. When I talk about it, I like to call it more ML ops for LLMs.
Mhm,
Um, so there's things that are similar to the ML ops that we know in the past, right? We have to think about how do we bring models to production, how do we manage production models, how do we monitor things in production, how do we automate things, like all these components of ML ops. There's things that are similar to when we're dealing with these large language models. There's also a lot of things new, right? Like you said, especially when production, if we do RAG, we have embedding databases, maybe do multiple LLM, maybe we are using multiple LLMs, doing multiple calls, we need to manage our prompts all of a sudden. Managing a prompt is different than
mhm,
managing maybe your data for prediction. So there's a lot of things new, and we're learning as well. So the course I've done is mainly on sort of ML ops for supervised fine tuning. So let's say if you want to fine tune your own model, what are some of those things that are still similar? So we have to create a pipeline where we do some data preparation, where we do the tuning, the automated deployment. We talked about some of the data preparation, generating instructions for your data set. I talked about deployment, monitoring, those types of things as an API. So a lot of things that we are now is similar. I think there's way more. There's like we can only teach so much
mhm,
in 1 hour with the deep learning AI courses. So there's more topics beyond that. So I think LLM ops is the field of where uh, of operating these large language models in production and everything that comes with it. So like I said, there's things that are new, and there's things that are still sort of that we know from the ML ops that we've done in the past year. So um, we're also still figuring things out. I think just to give an example, Niels, that like what's a good way of evaluating models?
mhm,
I think that's something we're still learning, and everyone is doing sort of giving their own spin. You can do things out of side by side, where you let the uh, two LLMs compete, and then an LLM decide who's the winner. You can use traditional metrics like blur or some of the other evaluation metrics are there. I very much believe in having humans evaluate sort of the output
mhm,
as well, especially if you want to do also reinforcement learning. So a lot of these things are still evolving, and we're learning. Also, how do you monitor these models in production? You probably want to monitor also the output. If there's nothing sort of in
mhm,
the output that you don't want to show to an end user. So I think we're learning while we're going. So I don't wouldn't say that the field of LLM ops is very, we're sort of, it is not that we're sort of 100% clear on what's in there, but we know what is important at the moment, and it's very much an evolving field. And I think it's a good field to be in, and exciting to learn about.
Mm-hmm.
And we try to teach some of the concepts in that 1 hour course.
Well, sounds like a super interesting course, and yeah, I think that's a very, very good point that you mentioned. That's monitoring. How do you monitor a large language model? Because a traditional, let's call it traditional ML algorithm, you make predictions
Yes.
and then you get the target and you can evaluate, okay, did my model perform well or not? But with LLMs, I'm curious to how do you currently do to evaluate the model, and how do you know whether the answers are good or not? I mean, user feedback is one. Are there other things that you look into?
Look, I wanted to ask you this question. What is it you're seeing across the board? So I see, look, I see different ways of doing it. I think I talked about the auto side by side. It's a technique that's being published, and Google has some technology in that space where you automate the process of evaluation. There's a, everyone sort of, there's been metrics out there that folks use. There've been benchmarks that folks are using. There's new ones that folks are inventing or trying. You can come up with your own. And there's human evaluation. So what I think is important here is that it's an evolving field. We're all learning. There's not one solution for all. It depends very much, again, yet I know it's a boring answer, but it depends on your use case, on your own
Mm-hmm.
requirements. What do you think is important? Let's say if you build a product where like a human, more human-like response is important, that will be, it's versus where you want a very much a sort of response that is more something like a computer would generate, very accurate but very structured and very condensed. Like, it depends on the use case. So and the way you what do you think is important for your use case? But I think what is important when thinking about evaluation is that you ask the question to maybe the product team or your users, like what is important for them, and then
Mm-hmm.
take that into account, and then look at what are the best options for us now. And I think it's a combination of things. From what I've seen, is that you want to maybe do some automated evaluation in the early stages when you maybe do tuning, or you test the Gemini API, and or you test your prompts, you test things like that. You do, maybe you eyeball first a bit, and then you run a bit of a larger evaluation, and then you maybe have, after that, you have humans look at it, you take that feedback into account. So, and I think it's a continuous process as well, like we've seen in the past, right? Evaluation is not, you do that this one at one moment and then you're done. You
Mm-hmm.
want to continuously evaluate things over time as well. Um, and then the question is also, how do you monitor things, right? So how do you
Mm-hmm.
monitor things like, and I'm going to ask you here this question, Neil, is that maybe, like, let's say in the past we did skew and drift monitoring, right, of data, of
Mm-hmm.
structured data. But how would you do that with a prompt, right? Because
Mm-hmm.
maybe the way, like, let's say you have a use case where a user writes something, a prompt, like that can change over time as well, and influences maybe the output. So it's, or how users interact with the large language model and the system can change. So how do you monitor things like that? I think that's something we're trying to figure out as well.
Yeah, it's a good. Yeah, it's actually a difficult problem. I worked once. I mean, I'm not a Gen AI expert, but I did one a work for one client, and one idea we had, which we ended up not doing it because of time constraint. But what we wanted to do is you basically user feedback. So you ask a well, user ask a question, you give it an answer, and then you ask the user to thumbs up, thumbs down, and then you keep track of this. You store something on BigQuery or whatever, and at least you keep track of your model's performance. And if you get lots of thumbs up and then suddenly lots of thumbs down, then maybe there is, I mean, the key is basically monitoring that, I think, user feedback,
Yeah.
and having a good, robust monitoring. Like, you need to know what was the input, the prompt, what was the output. If there are other parameters, take them into account as well. With LLMs, there are so many things you need. Like if you
Oh,
change the temperature or whatever, you can have a different answer. So make sure you have a robust monitoring. And then if you've got all of this, you can at least do some data analysis around this and try
yeah.
to maybe feed that into another LLM and ask them, okay, what are the different categories for the thumbs down? And this can help you using LLM to evaluate basically
Oh,
your performance. But
100%.
it's a very tricky problem, and it's not set in stone like a traditional ML model where you look at data drift, as you mentioned, or you look at
Exactly.
the
Yeah.
accuracy change.
Exactly. I think it's a very interesting field, and Google is doing a lot in this field, and stay tuned. There will be, I think, announcements and things coming up as well. So it's evolving. I think it's important. Like, what's your use case? What are your requirements? I think that's what it all starts with. And I also want to say, I'm not sure if anyone has ever read the I think they're called machine learning principles from Google. It's
Mm-hmm.
written by some of our engineers and research. They're like years old, and when
Yeah.
I read them, still now they're still true. And the first one I love. I still say it now, especially now. I say it is that like shipping a Gen AI use case or LLM use case in itself is not a goal. You should The goal should be you're trying to solve a problem or build a feature or something, and shipping that first, maybe without a large language model in it or Gen AI in it, is also okay, right? And if you do that
Mm-hmm.
later, or maybe you don't even need it, that is fine. So it shouldn't be a goal in itself. So I think everything comes down to the use case, what you're trying to solve, and then figuring out, okay, is it even a good solution for this? And then it comes down to, like you said as well, choosing the model, trying different models, evaluating, and then bringing it to production. That whole route. I still like that. What the research team has written back then, that it's good to think about that. So it shouldn't be a goal in itself.
Okay, one last question I have on LLMOps is deploying models. Is it? I've never deployed LLMs, but how is it compared to traditional algorithms? Is it the same? Is the deployment process the same, or is there a difference between the two?
So what is for me is just a game changer is that you have these really good models like Gemini that are already APIs.
Yeah.
So like building a use case without having to sort of deal with this deployment and everything is just already amazing. And you have SDKs to integrate with, and it's just shipping something is so much easier these days than when I started in 2017. So for me, that is just still mind blowing. Um, if you choose for certain reasons, requirements, maybe to take an open source model like Gemma, um, it's a bit more difficult because these models are still quite large, although they're smaller than the ones that you have
Mm-hmm.
as an API, like Gemini API, Gemini Pro. Um, is that you probably need to have a GPU resources, and you need to sort of wrap things into. You need to package it into a container and use something like Fast API and deploy it on a platform like Vertex. So luckily, cloud has made a lot of that easier, like you said, Neil. So I think, but you need to do more work yourself, right? So it it's back to what you're used to, probably like with deploying models in the past. You need to create your own you need to wrap things in a container and deploy it as an API. But luckily, that has become easier these days as well. With GPUs, sometimes you can run into some tricky things with like libraries. There's different, like you have the
Mm-hmm.
NVIDIA libraries, then you have your Python version, then maybe you have the library of the model you're using, and there can be some with error. So you maybe have to debug a bit more things. But yeah, it has become um, easier thanks to cloud, but also thanks to the community. Everyone who's building awesome examples and sharing code on GitHub, and that's very cool. And thanks to podcasts like this, folks talking about what they've done. So no, it's really, if you compare it to when I started in my career, it's so knowledge is so much more general available on this topic. So we're in a good place, and it's so cool to see what everyone builds. But yeah, for me, it's still, if I look back and just to where we started it off, is that when I started, And what we have now,
Yeah.
in 10 years, we came such, I sound very old now, we came such a long way. And it has become so much easier to deploy use cases with AI in it, and especially now with these great APIs and SDKs. It's just like you can use the Vertex SDK and Gemini, and you can prototype something within a couple of hours. It's or like within an hour. It's that is so impressive. Where I had in the past had to sort of collect data, train a model, debug TensorFlow 1.0 code, and things like that. So it's yeah, I'm very happy. Um, it has become a bit easier for all of us.
So I want to move on to the last part of the podcast. Just two questions on your career before we wrap up the episodes. The first one is, well, the show is called AI Stories. So I'm keen for you to tell us a story. It can be anything, something funny, a mistake you've made in the past. Yeah, whatever you want, but one story about yourself.
Yeah, so a fun fact actually is that I've worked for Google in Amsterdam. I've been living now in Singapore for many years as a foreigner in Asia, which is amazing. So I probably did a lot of things wrong as a European in Asia, that sort of because of the culture differences. But I grew up on a very small island. So I grew up, and fun fact here is the Netherlands has actually a few islands. So I grew up most part of my youth on a very, very small island where we didn't know about startups and technology and things like
Hmm.
that. And then I ended up now in a very small island, Singapore, in Asia. So it's been quite a journey, and a lot is thanks to Google.
Yeah, the last question is the classic one I ask all my guests. If you had one advice for someone to progress in their career, what would
Oh,
it be? Just one advice.
build things, build things, build things, build things. So especially if you're in your career and you're an engineer, like especially and you're early in your career, just build as many projects as you can. Help others with projects. Go work at a startup and build things. So the more you build, the more mistakes you make. The in my opinion, the better you get. Especially shipping products and shipping sort of machine learning. I think that has been very powerful for me. And then if you go up in your career and you grow up in levels and you start hiring teams and things like that, other skill sets become important. Some people want to stay close to just building things. Others want to progress and start leading teams. Then it's a different skill set. But I think it's if you're going to lead in the future technical teams, and I've been hiring technical teams and leading technical teams, is that having a solid technical background gives you also credibility when you lead teams. So I
Mhm.
think starting off with building things, getting a lot of experience, I think is going to help you if either way, if you want to stay in IC and build things, or
Mhm.
if you want to go into leadership, it also gives you credibility that you build things. So I think those, uh, yeah, that is definitely
Mhm.
something I would do.
Well, thanks a lot, Erwin. It was great to have you on the show and learn from you and your career. Have a great afternoon in Singapore then, and hope to catch up very soon.
Thank you very much. Thanks everyone for listening.
Thank you.